Good evening, Algebra 2. Today we are going to be talking about 11.1, which is the Introduction to Polynomials. So this is going to be the basis behind everything we do in Chapter 11, so pay very close attention. A polynomial, you already know what a polynomial is. You know, x squared minus 3x plus 5 is a polynomial, of course. But let's go ahead and give it a formal definition so we can explicitly say what a polynomial is. So a polynomial is an expression of the form a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power. So this is our first term here. This guy is our second term here. That's why we subtracted 1 off. It would be the next term. And then plus, now we're going to go 2 terms out. So n minus 2, x to the n minus 2 power, plus dot, dot, dot. We could have as many terms as we wanted to in between here, but eventually we are going to get down to the a sub 1 power x to the first power plus a sub 0, which we would pair with x up to the 0 power, but we know anything to the 0 power is going to be 1 anyway, so this guy actually just ends up being a constant. However, we need to add the following. We'd say where n is a positive integer and a sub n cannot be 0. Sorry, I hope you can read that. That says a sub n cannot be 0. So just as an example of a polynomial, let's say we had something like 3x to the 4th power minus 5x cubed plus 2x minus 1. So the degree of the polynomial, this next thing here, is the largest exponent of the variable. So our variable in this guy is x, and we have x to the 4th power, x to the 3rd power, x to the, this guy would be to the 1st power if you don't see one there, and then 1, which x would be to the 0 power here, so that doesn't really give us anything. So the largest exponent that you see here is 4, so the degree of that guy is 4. Okay. Your terms are each monomial separated by the plus or minus sign. So 3x to the 4th power is one term. Negative 5x to the 3rd is another term. Positive 2x to the 1st power is another term. And this last guy is negative 1. It is also a term, even though it doesn't have an or a variable, excuse me. So if you were to ask to classify how many terms does this guy have, you would say it is also a 4-term polynomial. Okay. Now it's a coincidence that both of these are 4. It doesn't have to be that way. We could, you know, add a plus y on the end, and then that would become a 5-term if we added that 5th term in there. So 5-term if we wanted to. But, you know, depending on how many you have, you just basically count what's separated by each sign. Alrighty, so a couple of other things we need to know are what standard form is, because you will be asked to actually put things into standard form. So when it asks you that, it means that it wants you to go from the highest exponent down to the lowest exponent. So let's say, for example, you were asked to put the polynomial 2 plus 3x squared minus 4x cubed plus x into standard form. So you would start with your highest exponent thing, which would be negative 4x cubed. So you actually want to take that negative, always goes with the thing that's behind it. So into standard form would be negative 4x cubed. It would be your first term. And then you go down from there. So if you want, you can cross them out. Our next one would be this plus 3x squared. So plus 3x squared. And that one's gone. Then we go between 2 and x. This guy actually has an exponent of 1, so this guy is next. Plus x. And then finally this 2, it doesn't have a sign, but if we were to assume it would be positive, so we would say plus 2 back here. And the reason why this guy comes last is because technically this is 2x to the 0 power, but x to the 0 is really just 1, so this is just the same as saying 2. So since 0 is lower than 1, that's why this one goes at the end. If you ever have a constant term, that one's always going to go at the end here. Notice now we're 3, 2, 1, 0, so we are in highest exponent to lowest exponent order. Next thing you need to talk about is your leading coefficient, and that's the number in front of the term with the highest exponent. So for instance, well, we already reordered this one, so obviously for this guy, you have negative 4x cubed plus 3x squared plus x plus 2. The highest exponent thing is this guy, so your leading coefficient is just the number out front, which would be negative 4. So the leading coefficient for this guy is a negative 4. You always got to take the sign with you. So your leading coefficient here is negative 4. Even if it was still in this old form here, not standard form, you'd have to look for the highest exponent stuff. Yeah, it happens to be in the middle, but your leading coefficient is still going to be this negative 4. So you got to think, oh, if I were to reorder this, which one would actually be leading here? Okay, so be careful with that. When you're asked to expand the polynomial, that means to multiply out the product of polynomials. So most often you're going to see it when you have something like this, 3x plus 2 squared. So that means to actually multiply it out. So now we know when we square something, that just means take this thing times itself again. So we have 3x plus 2 times the quantity 3x plus 2, and now we have a binomial times a binomial. We actually need to FOIL this guy, so then we do 3x times 3x, which is 9x squared. Then we have 3x times a positive 2, which is a plus 6x, and then 2 times 3x, which is another plus 6x. And then finally our last 2 times 2 gives us 4. And then I kind of went up here in the corner, sorry, but we're actually going to combine this 6x and this 6x, so we have 9x squared plus 12x plus 4. So when it asks you to actually expand that polynomial, it actually does want you to multiply the whole thing out. So not just write it like this. A lot of people think that's expanding it. And yeah, I know this is smaller, but when they say expand it out, they actually want you to multiply out the product of the polynomials. So get it down into its simplest form is essentially what that means. Okay, example 1 says expand the following polynomial and put the result in standard form. So your polynomial to begin with, let me get my pen here. Your polynomial is 3x squared in parentheses plus 4, and we're taking that and we are squaring it. Okay, so remember again, squaring means essentially to multiply the same thing twice. So to write that out, we have 3x squared plus 4 literally twice. So you should see the exact same thing twice. Don't just square each piece and call it a day. We actually have to, because we have a binomial times a binomial, we have to FOIL, which means to do the firsts times each other. So 3 times 3 is 9. X squared times x squared is x to the 4th power. We need our outers, so 3x squared plus, or excuse me, times a positive 4 is a positive 12x squared. Positive 4 times 3x squared is another positive 12x squared. So first outers, inners, and finally last, so positive 4 times positive 4 is a positive 16. And then since these two terms are both x squared, we can actually add them together. So 9x to the 4th power, sorry, that should be a 4, plus 12x squared plus 12x squared is a 24, sorry, 24 x to the 2nd power still. X to the 2nd power, sorry, that should be a 2, plus 16. So it says to put it in standard form. We kind of already are in standard form, but let me just clean this up. You guys probably don't need to rewrite it again. 9x to the 4th power plus 24x squared, and then plus 16. So that is actually our answer for expanding the polynomial. Now they would like to know what is its degree. So the highest thing, it's in standard form already, because we go from the highest exponent down to the lowest. And its degree would be your highest exponent, which would be 4. So this guy has a degree of 4. And what is your leading coefficient? Well, that's on the term. That is your highest exponent. But it's not your exponent this time. Our leading coefficient is actually going to be 9 this time. So it's the coefficient, which is the number out front of the highest degree term. I have a couple more examples to show you, but I will go ahead and save those for the next video, so please tune back in for video number 2. Thank you.